Welcome. This is the first video regarding histograms, and we're going to roughly cover section 15.1 in your book. So 15.1 is called Graphs and Charts, and it covers other different types of graphics besides histograms, but our major goal is going to be interpret histograms of a single variable. So the first thing that we should look at with the histograms is the data set. So you think about one single variable and all the values it can take. And what we mean by that is, or as an example of that, is think about heights of people. If you collect a group of people, we'll call them the sample, and you measure all their heights, that's one piece of data that you're talking about. And it will likely take on many values. So if you'll have a list of numbers that represents height, a collection of numbers, heights of all the individuals. We're just going to call that the distribution or the data set. And it's okay for that distribution to contain repeats. That's saying it's okay for people to be the same height. We just make sure we write those numbers down twice, or however many times they're present in the sample. So the example that we're going to run with through these videos are scores in a math class. So this is an ordered list of scores. You can tell that it's in order because numbers have something lower to the left and something equal or larger to the right. And you can see that there are about exactly 20 scores here. So to construct the histogram, the first thing to do is to sort all of these numbers into so-called bins. And the bins are made by a range of values, and the size of the bin is called, the bin size references how wide the range of values that can fall into the bin. So here below, we have a bin labeled 0 to 10, and what we're going to write in the frequency is 0 because there are no scores. Nobody scored. Between 0 and 10. Likewise, for from 10 to 20, there were no scores. From 20 to 30, there were no scores. From 30 to 40, there were no scores. And there was one score between 40 and 50. So that score has been sorted. Between 50 and 60, nobody scored. And between 60 and 70, there were another 2 scores. Now, between 70 and 80, we have an issue with the boundary because there are scores that are 80. And so we have to wonder, in which bin are we going to count them in? Are they going to go into the left bin or the right bin? And you know that they shouldn't go into both bins, because what we're trying to do is count how many people scored between a range of values. So it's not going to be helpful to double count the people who scored 80. They don't deserve overrepresentation just because they lie on the boundary line. And so the way around this is to just make a choice. It doesn't really matter which choice you make, but you just have to stay consistent. So we're going to choose 80 should fall on the right. And what being consistent here implies is if we have anybody who scores a 90, that means people on the 90 edge should also go to the right. And if anybody scored a 100, we would need another bin so that anybody who scored exactly 100 would go to the right. So it's just choosing to be consistent. And you want this because we don't want to make one bin larger than the other ones. They should all be the same size, and we should just follow a consistent rule because it's easier to interpret then. So what does that really mean? It means that there are 4 people who score between 70 and 80. Between 80 and 90, we don't count the 90 because the 90 is going to be counted in the next one. You have 8 scores. And from 90 to 100, you have 5 scores. And you can check 1 plus 2 is 3. 3 plus 4 is 7. 7 plus 8 is 15. And 15 plus 5 is 20. So we have exactly accounted for all the scores in this list. The next thing to do is to use those bin sizes, or the names of the bins, to mark off on the horizontal of our grid the values that define the boundaries of the bin. So you could have done this with another bin size, but we just chose 10. So these are scores. And on the vertical, you are going to make room for all the scores that you counted previously. So the highest frequency score was between 80 and 90, and there were 8 of those. So we just need to make sure the scale that we set up over here, we're like counting up by 1 right now, but we could have counted up by 2 or a half. We just need to make sure there's room for an 8. And the last thing to do is to build a bar for each bin. So each bin gets a bar, and the height of that bar is going to be equal to the frequency. So the first bar that has a height is the one between 40 and 50. So we'll just draw a little bar. Between 60 and 70, we have a height of 2. Between 50 and 60, and the ones off to the left, I mean, there's kind of a bar there, but its height is 0. So we don't really show it. From 70 to 80, we had 4 scores. So our bar will be at a height of 4. From 80 to 90, we had 8 scores. So we need a bar that is 8 tall. And from 90 to 100, we had 5 scores. And so now we have a visual representation of that list, those scores. You can get an at-a-glance understanding of how the class kind of did as a whole. And you can read from one particular bar, so say this bar right here, exactly how many people scored between 70 and 80. This bar says 4 people. 70 and 80. Another nice thing about the histogram and the visual representation is because the bar that is just to the right of 70 to 80 is twice as tall, you can see that twice as many people scored between 80 and 90 as between 70 and 80. And that's just something you can get immediate from the visual that is harder to grab from the initial data set. So that's what a histogram is, and the next videos will talk about different ways to alter the histogram to still communicate the same information, but in slightly different ways. Okay, see you there.